morning to all of you. Today I will do the subject engineering mechanics. The last chapter is last class virtual work. Today I will continue this chapter virtual work engineering mechanics. Clear? The chapter name is virtual work. Last class I have given idea about simple supported beam carrying point load. Now I will do simple supported beam carrying UDL. Clear? Application of virtual work to simply supported beam carrying UDL, right? Informally distributed load. Now this is simple supported beam AB. This carries UDL supported A at B. Clear? This is beam AB. The UDL is double Newton per meter. Length L. Clear? So what is the load? Total load is found out by multiplying UDL with length of the beam. I have already discussed regarding this matter, regarding this UDL. Previously I have discussed what is UDL. Clear? Now UDL is equal to double Newton per meter length, total length L. So total load is found out by multiplying UDL with length and acting at the CG of the beam. What is CG? L by 2. Right? This is double is equal to small w L. Clear? This is L by 2. This is L by 2. Right? This is RA. This is RB. First find out what is RA, then find out what is RB. Right? Using principle of virtual work, find out RA, find out RB. Now, this is B may be. This is UDL load, total load W, small double L. Clear? This is A, this is point B, this is L. Now, here, give a virtual dispersion Y at B or A, right? Suppose this is Y. So beam, this is AB, right? B move to B dash, C move to C dash. So this is RB, this is double. Clear? Total length L, this L by 2, this L by 2. Now this point C, let RA is equal to reaction at A. Clear? What is RB is equal to reaction at A B. Clear? Give an upward displacement, displacement y at B, y at B. Clear? That is B moves to B dash through distance y. That means RB move from B to B dash. The corresponding displacement, the corresponding virtual displacement at C is x. Clear? If B moves to B dash, C moves to C dash. That is, if this is y, is equal to x. Right? What double is equal to? Small double del. If B moves to B dash, C moves to C dash. This is C dash. And A at the same position. So displacement RB. This is RB. This is RA. Clear? So virtual difference RB is equal to y, RA 0, double x. Now find out x in terms of y. From figure, x by L by 2 is equal to RE by y by L. Clear? This length is equal to this length by total length. Now, what is x is equal to? Y into L by 2 by L, y by 2. So what is x is equal to? Y by 2. This is x in terms of y. Now apply principle of virtual arc to the entire beam. There are three forces: RB, W, RA. According to principle of virtual arc, according to principle of virtual arc, sigma v dot is 0. Clear? 0. So upward force positive, downward force negative. So RB into y minus double x plus R into 0 is equal to 0. Clear? This is 0. So RB into y is equal to W into X. This implies RB into Y is equal to what W? Double L. X. What is X is equal to? Y by 2. Y cancels each other, each side. Both sides Y cancels. What is RB is equal to? Double L by 2. This is value of RB. Now, what is RA plus RB is equal to? Double L. Clear? What is RA is equal to? Double L minus RB. Double L minus double L 2. What is RA is equal to? Double L by 2. Right? This is RB. This is RA. I'll do one problem for this theory. The question is, what is the question number? This is question number 77. The question is, a simple supported beam carrying UDL, a simply supported beam carrying UDL, and point load shown figure, right? A, B, simple supported beam at A and B, point load 5 kilonewton, UDL 2 kilonewton per meter for length of 3 meter. Find the reaction RA and RB using principle of virtual work. Clear? Now, let RA is equal to reaction at A. What is RB is equal to? Reaction at A, B. Clear? Now first make load calculation. So 2 kilonewton per meter over length of 3 meter. 2 kilonewton per meter over length of 3 meter. Right? What total load? WL acting at L by 2. This is 2 into 3, 6 kilonewton. What this length? 1.5 meter. What this length? 1.5 meter. Right? This is 1.5 meter. This is 1.5 meter. Now give some virtual displacement y at B. Right? Suppose this is B may be. This is beam, a beam. This is RB, this is RA. RA, this is RB. Clear? This is 3 kilonewton, 6 kilonewton. This is 5 kilonewton. This point C, D, E. Clear? This point E. What this length? This length 1.5 meter. This length 1.5 meter. This length 1 meter. This 1 meter. Right. Now give a virtual displacement y at B. At a B. Suppose B move to B dash. Clear? E move to E dash. D move to D dash. C move to C dash. Clear? At A, the distance is 0. Suppose this is y. Suppose this is x. This is z. Then this is z. Clear? Give assume or give a virtual displacement y at B to B dash to B dash. Clear? The corresponding virtual displacement at E is x. Clear? C is z and at C is z. Right? At C this is z, E x, at B y. Now first find out x and z in terms of y. Clear? Find out x and z in terms of y. So from figure x by 1 is equal to z by 1 is equal to x by 3.5, y by 5 total length. So what is z is equal to this equal to this to y into 1 by 5. So y by 5 equal to this side, both this. What is x is equal to 3.5 by 5y. This is x, z. Right? Apply principle of Vertual to the entire beam. Apply principle of virtual work to B may be clear. That is sigma V double is equal to 0. Now start from this side. RA into 0 minus 5 into ZA minus 6 into XA plus RB into Y 0. Right? This is 0. What is RB into Y is equal to 5ZA plus 6X. Clear? Putting value of Z and X, both sides Y cancels, you find out RB. Next, what is RA plus RB is equal to? RA plus RB is equal to, what is RA plus RB? 5 plus 6, 11 kilonewton. What is RA is equal to? 11 minus RB. Clear? Find this answer. This is RA, this is RB. Now, application of principle of Vertual to ladders. Clear? Next, application of principle of virtual work to ladders. Clear? Ladders. Now, I have discussed in friction chapter what is ladder friction. This is also same as that theory, but something different. Clear? This is ladder friction, this is ladder. This ladder. Right? This ladder AB, weight W, weight is W. Clear? At A, the reactions are A. At B, the reactions are B. Clear? The ladder slips away from the wall. So friction is acting towards the wall FA. Clear? The ladder slips away from the wall. So friction is acting towards the wall. Similarly, the ladder slips downwards. Hence, the friction will act upwards. This is a B. Clear? Now, the ladder at point B slip downward. At A, the ladder moves away from the wall. So in both cases, the frictional force is acting. At B, the frictional force is acting upwards. At A, the frictional force is acting towards the wall. Right? Now, what is the virtual displacement of RA, RB, FA, FB? See here. The ladder slips in this side towards left away from the wall along the line of action of force FA. Similarly, the ladder slips downwards and the distance is along the line of action of FB. Clear? So, some work will be done by FA and FB, but no work will be done by RA and RB. Why? Because ladder slips horizontally and reaction is acting vertically. No virtual displacement along the line of action of RA. So what is distance of RA? 0. So what done by RA is equal to 0. Clear? Similarly, at point B, the ladder slips along the wall, along FB, but the RB reaction RB is normal to the wall. Its virtual displacement is 0, so its work done is 0. Clear? Now I will give the theory. The figure shows ladder AB. Ladder, clear? Rests at A, leans at B, right? It rests. It rests at A and leans at B. Clear? At A, B. At A, the ladder slips or first start from B. At B, the ladder slips downward along with wall, along the wall, right? So there is no virtual displacement for RB, but only for FB. At B, the ladder slips downwards along the wall means along the line of action of force AB. Clear? That is along the line of action of AB. Right? So, some work will be done by AB, but no work is done. Hence, some virtual work will be done by a clear, but no work will be done by RB, but no work will be done by RB, clear. Similarly, at a the leader sweeps away from the wall, away from the wall. Hence, friction is acting, friction Fa will acting towards the wall, and the vertical displacement is along the line of action of Fa, and the vertical displacement is along the line of action of Fa. Clear? Hence, 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 some virtual work done is what will be done. Virtual work done will be by Fa, by Fa. Clear? Not by Ra. No work will be done. No virtual work will be done by Fa, by Ra. Clear? By double also work will be done. Also, some virtual displacement will be occur by W. So, apply the principle of virtual work. Now, apply the principle of virtual work. The principle of virtual work, that is sigma b double d 0 to solve the problem. Right? Now, note If wall is smooth, then what is B is equal to 0. No friction. Clear? Only work will be done by F and W. First case, work will be done by FB, W, FA. If wall is smooth, then FB 0, then the virtual work will be done by FA and W. Clear? Next, lifting machine. This is question number 78. The question is uniform ladder of weight 250 Newton rests against a smooth vertical wall, a rough horizontal floor, as shown figure, which makes angle 45 degree. This is 45 degree with horizontal. Clear? This angle 45 degree. Find the force of friction at the floor. What is FA? Using the principle of virtual work. Clear? This is question. This is letter AB. Clear? At A, no what will be RA. Because when D moves downwards, the ladder slips towards left, away from the wall. Hence, the friction is acting towards the wall. So some work will be done by FA, not by RA. Similarly, at B, since the wall is smooth, so friction at B FB 0, only RB. As ladder slips downwards, so no work done will be by RB. Clear? Only work will done by FA and W. Clear? Suppose this is distance Y. This distance Y. Clear? But this distance X. Clear? What distance? XY2. XY2. Clear? Consider when the point D moves downwards, moves downward, the ladder at the foot of the ladder at will move away from the wall, away from the wall. Clear? and frictional FA and the frictional force FA will move, will act towards the wall, towards the wall. Clear? Let us move this side, friction act to that side. Let now what done by RA 0. Clear? What done by RB 0. Right? RB 0. What done by AB 0? Because AB 0, so what done by AB also 0. Clear? So from figure, what is figure? Tan 45 is equal to this by this, y by x by 2, right? So this one is equal to x by 2. What is y is equal to x by 2? Clear? According to principle of virtual work, sigma v dot is equal to 0. Clear? This implies Fa into x minus double y 0. What W? 250 Newton. So Fa into x double is 250 into y. What y is equal to? What y is equal to? X by 2, 0. X cancels out, 125. What is Fa is equal to? 125 Newton. Here, this is Fa. This is your answer. Next theory, last theory, application of virtual arc to lifting machine. Clear? Application of virtual arc to lifting machine. Clear? So, in case of lifting machine, the effort moves downwards, load lifts upwards. Clear? So, in this case, the virtual work done, both the effort, load are found out. And apply the principle of virtual work to solve the problem. Clear? In case of In case of lifting machine, the load, the effort applies downwards, downwards, and the load moves upwards, and the load moves upwards. Clear? Clear? Suppose P is effort. P moves downwards, we will pull the effort downwards, lift it, weight will lift upwards. In this case, you are done with effort, loader are found out. Clear? Reply. In this case, in this case, you are done, the virtual are done, the virtual were done by the effort and a load are found out. Clear? And apply the principle of virtual work. The principle of virtual work, that is Cgm VDOLD 0. Clear? To solve the problem. To solve the problem. Clear? This is theory of virtual completes. Next class I will do 2 classes problems. Then I will start dynamics. Clear? Please make like, share, subscribe and watch the full video. Thank you.